we need to show that the second derivative of y with respect to x plus n squared y equals to 0 given if y equals to a cosine of nx plus b times sine of nx. So let's begin. So here we have y equals to a times cosine of nx plus b times sine of nx. So here a, b and n, these are all constant. Now what we'll do this, let's label this as equation number 1. We'll take equation number 1 and take the derivative on both sides with respect to x. So we have derivative of y with respect to x, so that will be equals to a is a constant, so that means simply a will get multiplied to derivative with respect to x of cosine of nx plus b times derivative with respect to x of sine nx. Now let's find out the value. So we have a times the derivative of the cosine function, that is negative sine of nx, and we need to use the chain rule, so we'll multiply it with derivative with respect to x of n times x plus b times derivative of the sine function will give us cosine of nx. So this is multiplied to derivative with respect to x of n times x. So that is equals to, so let's find out the value. So derivative with respect to x of n times x, so this will give us simply n. So we have negative a n times sine of nx plus b times cosine of nx, the derivative with respect to x of nx. So this is going to give us n. That's because, let me show you how this is true. So we have derivative with respect to x of nx. So here n is a constant, so we can pull it out of the derivative. So we have derivative with respect to x of x. We know the derivative of x with respect to x, that value is equals to 1. So that means we are left with the value n. Right. So this is derivative of y with respect to x. So let's label this as equation number 2. Now what we'll do, we will take the second derivative of equation number 2 of y. To do that, all we have to do is consider equation number 2 and take the derivative with respect to y with respect to x on both sides. So we have derivative with respect to x of dy over dx, and we will take the derivative of term by term. So here n times a, that's a constant, so we'll simply multiply it derivative with respect to x of sine of nx plus n times b. These are constants, so this will get multiplied to derivative with respect to x of cosine of n times x. So that's equals to negative n times a times derivative of the sine function is cosine function, so cosine of nx, multiplied to, we'll again have to use the chain rule. We'll multiply it to derivative of nx, which is simply n. So that means we have negative n squared plus n times b. The derivative of the cosine function gives us negative sine nx multiplied to derivative of nx, which is n. So that gives us n squared b. This will give us, so on the left hand side we have second derivative of y with respect to x. So that's equals to, so we'll take negative n squared as the common factor. So this will get multiplied to a times cosine of nx plus b times sine of nx. So this is equals to n squared times y, because it's given that y is equals to a times cosine of nx plus b times sine of nx. So this was what we labeled as equation number 1. So that means we can rearrange everything to get the second derivative of y with respect to x. So that's added to n squared y equals to 0. So this is what we are asked to prove.